Hello and welcome to the Friday, October 10th, 2025 edition of the SANS.edu Stormcast. My name is Johannes Ulrich, recording today from Denver, Colorado. And this episode is brought to you by the SANS.edu Credit Certificate Program in Purple Team Operations. And in diaries today, we do have another diary by one of our undergraduate interns. This time it's Yin Guan Lo, who wrote about a RedTail infection. RedTail is a cryptojacker, so essentially infecting your system in order to mine cryptocurrency, in this case, typically Monero. Now, what I like about this particular write-up is it doesn't just focus on exactly what hash, for example, was used or what IP address the attack came from. Quite often, defenders are a little bit overly concerned with these indicators of compromise. What's really more important to inform your defense is the TTPs that are being used by a particular attacker in order to identify certain weaknesses in your systems that you need to defend. In this example, for example, it's things like weak passwords, or for example, the modification of the .ssh authorized keys file in order to gain persistent access to the system. In particular, the later one is one of those things that's often not done very well. So you want to protect that authorized keys file, maybe make sure that it's only writable by the root user, or you deploy them centrally into a location other than the user's home directory, which of course also then makes it easier to detect any unauthorized modifications to this file. So overall, a nice approach here to look at a honeypot attack from this lens based on the MITRE attack matrix, and not just looking at these individual, very kind of ephemeral indicators of a compromise. Well, remember a week or two ago, I talked about the breach of the My SonicWall service. At the time, SonicWall published a blog post stating that a small number, I think they mentioned 3 or 5% of customers who used My SonicWall to back up their configuration had their configuration stolen from the My SonicWall cloud service. And they kind of blamed it, well, as so often, on the user. Apparently, those users had weak passwords. At least that's what was of the suggestion of the blog post, as they attributed the incident to password brute forcing. Now, yesterday, SonicWall did change their story. All configurations backed up to My SonicWall were compromised. So all users either had bad passwords or something else may happen. Well, apparently it wasn't the user's fault. It was SonicWall's fault. They also didn't initially scope the incident correctly, and as a result missed the fact that all configurations backed up to My SonicWall were compromised. They still take a little bit, security, I guess, from the fact that the passwords were hashed, but they were hashed in the firewall before they were uploaded to My SonicWall. All other parts of the configuration files were stored in the clear in SonicWall's cloud service. Cleaning up after this is, of course, the user's problem. You're supposed to change all credentials, even the ones that were hashed, because, of course, once an attacker has a hash credential, they're always able to brute force it. It's really just a matter of time, and I'm not sure exactly what hashing algorithms are in play here and how long it would take an attacker to crack a specific credential that they found in these configurations. And of course, in addition to the credentials, there's a lot of other network details in those configurations that have now also leaked. And Crowdstrike did today release patches for 2 vulnerabilities that affect the Falcon Windows client. Actually, I should call them issues, because in their advisory, Cloudflare says these are issues and logic errors. They do avoid the word vulnerabilities because that probably sounds worse for a company that makes a security product. Both of these vulnerabilities do allow a user who is already able to execute code on these systems to delete arbitrary files. It's really more sort of a Falcon sensor bypass vulnerability. Well, and then we have news about Ivanti, but not from Ivanti. The news comes from the Zero-Day Initiative. The Zero-Day Initiative today released 13 advisories affecting vulnerabilities in Ivanti, for which there is no patch available yet. The Zero-Day Initiative usually waits a certain amount of time before they're doing so. Now, Ivanti is aware of these vulnerabilities. For some of them, you will get a patch in November. For others, well, you will have to wait till March next year to get an update. These vulnerabilities are remote code execution vulnerabilities, SQL injection vulnerabilities, and other similar vulnerabilities that we have in the past seen heavily exploited against Ivanti products, in particular by ransomware gangs. So until March, good luck and hope your Ivanti instance will survive. But since it's Friday, I want to close on a positive note, and with that, we do have some research work from one of our SANS.edu master's degree students. Michael, could you introduce yourself, please?
Hi, thanks for having me. My name is Michael Samson. I just recently graduated from the SANS master's program, and been in the information security space for 12 plus years now, uh, doing everything from endpoint security work in the beginning to more application security, offensive security work later on, and now kind of use the offensive security skill sets to help with defensive. Um, and and you'll see the offensive security mindset in the research.
Yeah, so offense informs defense, as we always say. But your paper hit on a topic that actually is so timely. We had a number of issues with that recently. Can you explain a little bit what the paper was about?
Yeah, so the paper was about identifying the attack surface behind AI agents. So the initial uh, generative AI solutions that were out there, such as early days of ChatGPT. They were fairly simple AI chatbots, but today now you have AI agents that have access to various tools, and we're also leading to a world where you have interconnected AI agents, where you can have one AI agent calling another AI agent in the background to return your completion. And so there's a critical mesh of attack surface hiding behind an AI agent. So it's important to be able to map that, and so that was what the research was around, being able to start that discovery process.
So we're talking agents. Is this MCP, and so that protocol is being used here to connect different AI pieces?
Yeah, so MCP is the primary protocol being used now to expose tools to AI agents. But the way that I conducted the attack surface enumeration for this research was kind of protocol agnostic. So you could have tools exposed to an AI agent using a non-standardized method or protocol. And the idea is to still be able to detect that attack surface.
So the protocol is not a vulnerability. It's how you use that particular protocol. Is that sort of it? Like with HTTP, it's not HTTP. The problem may contribute, but the problem is the vulnerable website. Is that sort of the idea here?
Exactly. What are the common problems you'll likely see with tools exposed through an MCP server is just inadequate authorization checks. For example, when performing calls to various tools, which should be under um, the calling user's identity, but in a lot of cases, you may see those calls being conducted under a system identity, creating kind of Prevesc or cross-tenant compromise scenarios. But yeah, the protocol itself isn't the vulnerability; it's just a standardized way of exposing tools to an agent. But the way you expose the tools themselves, the way you write those wrappers around your API calls can be vulnerable.
Yeah. So I guess going back to the web application analogy, it's kind of like when I connect back to a database, it's usually sort of one user ID for all queries. it's not that the database really knows what front end user really sort of is sending the query back. So that's kind of one of the problems here. And then just similar to that, if my application messes up access control, well, the user is able to retrieve data they're not having access to. So that's really what we're dealing with here. Yeah. That's really interesting that we sort of have basically old vulnerabilities coming back here to haunt us. And I think that's a lot of what these are. Can you sort of walk us through sort of an example attack, sort of what this would look like in an application?
So the one vulnerability you may see is leaving the authentication process up to the AI agent. So maybe exposing a tool to the agent that authenticates the user and relying on the AI agent to properly pass that user identity to their next tool call that accepts the user ID as an argument, for example. And then in those scenarios, you can use things like chain of thought prompt injection to kind of convince the agent that, oh, you've already called this authentication tool, received this user ID, now go ahead and call this other tool in order to access data under that person's identity.
So the attack would basically be some form of prompt injection where I basically trick the AI agent into believing I'm someone else, or what would the prompt look like there? Do you have sort of an example, kind of?
Yeah, so the prompt could look like essentially some sort of like JSON structure where you have the going in a chain of thought confusion scenario, JSON object that acts as the output or receive from a tool. So maybe you have some sort of delimiter such dashes. You put in the JSON payload with the expected output from that tool call, that authentication tool call, or maybe user ID and what other attributes may exist. And then some other delimiter, and then the next prompt would be, or you made this tool call. Now go ahead and perform XYZ function, calling the next tool, and return the results to the user and submitting that prompt. And it does require that you kind of have some reconnaissance already around the tools that are available to the agent, the expected return values, the expected parameters. And that's what the research honed in on, is creating a way for you to enumerate those so then you can use those details for the prompt injection attack afterwards.
So complete attack, I first figure out what tools to use, how they exchange parameters, and then I find sort of these ways how to nest different prompts and such to basically expose one back-end tool to the prompt that I wouldn't have otherwise accessed.
Exactly.
That's really interesting. A little bit server-side request forgery, I guess, in there as well. Sort of that,
in a way, yeah.
So these patterns always come back. Yeah. So your paper explains all these details: how to enumerate it, how to find it. Your paper can be found in the SANS reading room or the cybersecurity research part of the SANS.edu website. Anything you want people to get away with it, or who should read the paper?
Yeah, so it's useful for anyone that has an AI agent that they're trying to secure, or if their organization is building AI agents and you'd like to test them to identify the attack surface behind them. It's great for that. There is also an open source tool that was released along with the research that you can use to get started with this attack surface enumeration. And that tool is linked at the bottom of the paper.
So excellent. So tool and paper, everything free to download from the SANS.edu website, or I assume GitHub for the tool. And thanks for joining me here, and thanks for talking about your paper. If anybody has any feedback or such, please let me know. And again, the link will be in the show notes. Thanks for listening, and talk to you again on Monday. Bye.